In this video, we'll walk through how FitConsent implements Google Consent Mode v2, from the dashboard configuration all the way to live validation in the browser. We'll cover the Direct Embed installation method using a live demonstration website, verify that all 4 consent mode signals are correctly set, and validate the behavior using browser developer tools and Google Tag Assistant. Let's get started. Before we look at the dashboard, let's take 60 seconds to understand what consent mode actually is and why it matters. Google offers 2 implementation modes for Consent Mode v2. The first is Basic Mode. Tags are completely blocked from firing until the user gives consent. It's strict, but it comes at a cost. Any user who leaves without interacting with the banner is invisible to your analytics. Attribution data is simply lost. The second is Advanced Mode, and this is what Google recommends. In Advanced Mode, tags are allowed to load immediately, but they operate with denied signals. Google's infrastructure then uses cookieless pings and behavioral modeling to recover attribution data for users who haven't consented. In practice, this recovers up to 70% of attribution data that Basic Mode would lose entirely. The trade-off is complexity. Advanced Mode requires the consent defaults to be injected into the data layer before any tag fires, and the correct signals must be present in every update call. And Google requires a registered partner ID in the payload to verify the signals are coming from a certified CMP. Managing all of this manually is error-prone. FitConsent automates the entire technical handshake. It handles the signal injection, the timing, and the partner ID, so that what reaches Google is always valid and compliant. Let's open the dashboard and see how it's set up. Now let's see how simple the configuration actually is. In the FitConsent dashboard, you'll see your website's overview listing all your registered properties. To add a new one, click Add Website in the top right and enter your domain. Once created, click Configure Website to open the configuration page. The configuration page is organized into tabs. Let's go through the ones relevant to this setup. Start with the General tab. Here you enter your GA4 measurement ID, which links FitConsent to your Google Analytics property. Below that, set the legislative framework to Auto. This enables dynamic detection. So FitConsent automatically applies the correct legal framework based on the visitor's location. The most important toggle on this page is Google Consent Mode v2. Set this to Advanced. When Advanced is enabled, FitConsent injects the Google Partner ID into every consent update call, certifying the signals as CMP compliant. Moving to the Appearance tab. This is where you control the consent banner's look and feel, colors, position, and layout. These settings don't affect the consent signals, but they determine what the user sees and interacts with. The Content tab is where you manage the text displayed in the banner, the title, the description, and the button labels. You can also manage translations here if your website serves multiple languages, which is the case for the demonstration site we'll use in this video. Finally, the Behavior tab controls how users interact with the banner. You can enable or disable the display of the Decline button, depending on the legal framework. You can also enable or disable the display of the Manage tab. Once these settings are configured and saved, FitConsent is ready. The actual consent enforcement happens through the embed script, which we'll look at next. Navigate to the Integration tab and select Code and Integration. 3 sub-tabs appear: Direct Embed, Google Tag Manager, and other platforms. We're on Direct Embed. The embed code shown here is the complete snippet you paste into the head section of every page before any other scripts. Let's read through what it does. The first block initializes the data layer and the tag helper function. It then immediately calls tag consent default, setting all 4 signals: add storage, add user data, add personalization, and analytics storage to denied. Notice this line, developer ID set to true. This is the Google CMP partner ID, and FitConsent injects it directly into the consent default call, not as an afterthought, but as part of the very first signal Google receives. This is what registers FitConsent as a CMP responsible for this consent state. Below the script block, there's a placeholder comment indicating where your own scripts, Google Analytics, Google Ads, and so on should be loaded. This ordering is deliberate. Defaults first, your tags second. The final line loads the FitConsent banner script asynchronously. This is the script that renders the banner, handles the user's choice, and fires the tag consent update call once a decision is made. You'll also notice a second snippet at the bottom of the page, the embeddable storage declaration. This is an optional component you can add to your privacy policy page to display a full table of all cookies and storage types used on the site. It's separate from the consent logic itself. For Google Tag Manager users, switching to the GTM subtab provides the equivalent setup steps using the official FitConsent GTM community template. The consent behavior is identical. GTM is simply the recommended method for tag-managed environments. We're now on the FitConsent demonstration website. This page has the Direct Embed snippet installed, exactly as shown in the dashboard. Let's open Browser DevTools and switch to the Console tab. Type dataLayer and press Enter. The console returns an array of 6 entries. This is everything that has been pushed to the dataLayer since the page loaded. Now let's expand the first entry, index 0. This is the consent default call. You can see the 3 arguments that make up this call: consent, default, and then the consent object itself. Inside that object, all 4 signals are set to denied: add personalization, add storage, add user data, and analytic storage. Notice developer ID set to true is already here in the default call. FitConsent doesn't wait for the user to interact before registering as the active CMP. Google sees the partner ID from the very first signal, before any user choice is made. Also note GTM.UniqueEventID1, the lowest event ID in the entire data layer, which confirms the consent default fired first, ahead of everything else, including the GA4 config call visible at index 2. Looking at the rest of the data layer, index 1 is the tag JS initialization. Index 2 is the GA4 property config, and index 3 is the GTM.DOM event marking when the DOM became ready. A consent update is already present at index 4. FitConsent detected a previously stored consent preference from this browser session and automatically restored it. This is corrected advanced mode behavior. The default is always set first, then the stored preference is applied immediately. This happens without requiring the user to interact with the banner again. In a fresh session with no stored preferences, only the default would appear here, and the banner would be visible waiting for user input. Now let's click Accept All and watch the data layer respond. Now let's interact with the banner. We'll click Accept All on the FitConsent banner. Back in the console, instead of inspecting the full data layer, let's filter it to show only the consent-related entries. dataLayer.filter, where E goes to E at index 0, is strictly equal to the string consent. This returns an array of exactly 3 entries, and together they tell the complete consent lifecycle story. Entry 0 is the consent default, arguments consent and default, with all 4 signals denied. This is the starting state, the gate that holds all tags back before any user decision is made. Notice developer ID is already here in GTM.UniqueEventID1, the very first event in the data layer. Entry 1 is a consent update with all 4 signals still denied, GTM.UniqueEventID7. This is FitConsent restoring a previously stored preference from this browser session. Even when restoring a denied state, FitConsent fires a proper update call. It never silently skips the signal. This is correct advanced mode behavior. Entry 2 is the update we just triggered by clicking Accept All. Arguments consent and update GTM.UniqueEventID9. Expand the consent object. Add personalization granted, add storage granted, add user data granted, analytic storage granted, developer ID true. All 4 signals are granted, and the partner ID is present here too. In every single consent call FitConsent makes, whether default, denied update, or granted update. Google always knows which CMP is responsible for the signal. That's what qualifies FitConsent as an active and compliant CMP. The event ID sequence 1, then 7, then 9 confirms the correct order. Defaults first, stored state restored, user action last. No signal was fired out of order, and no tag could have fired with stale consent state. Next, let's cross-check all of this using Google Tag Assistant. Now let's validate the same behavior from Google's own tooling, Tag Assistant. We've connected Tag Assistant to the FitConsent demo page. You can see it has detected one Google tag, G7Q46015QKF, which is the GA4 property configured on this site. On the left, Tag Assistant shows the full event timeline in the order they fired. Reading from the bottom up, consent default is event 1, the very first thing that happened on the page. This confirms what we saw in the data layer. Then consent initialization, container loaded, config, consent update, DOM ready, and finally window loaded. This ordering confirms what we saw in the data layer. Consent defaults are established before any tag initialization occurs. Navigate to the Consent tab. This is the event consent state table, Tag Assistant's direct view into the consent signals Google received. This is where consent compliance is confirmed. Before interacting with the banner, all 4 rows show the same 3 values: denied, 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 across on-page default, on-page update, and current state. The 4 purposes are add storage, analytic storage, add user data, and add personalization. You also see a 5th row for developer ID, the FitConsent partner ID, which Tag Assistant lists separately as an identifier field. This distinguishes it from the 4 consent purposes above. Now let's click Accept All on the FitConsent banner and watch the timeline update. The event list on the left grows, new events appear, a second consent update, followed by user_engagement and consent_update. These are Google's own events firing in response to the granted signals. The page is now fully measurable. Back in the Consent tab, the table has updated. The on-page default column still shows denied for all 4 signals. That's correct, the defaults never change. But the on-page update and current state columns now show granted across all 4. Add storage granted, analytic storage granted, add user data granted, add personalization granted. All 4 consent purposes confirmed. All 4 consent mode v2 purposes are confirmed as granted by an independent Google tool. The developer_ID row remains as denied in Tag Assistant. This is expected behavior, as it is a CMP identifier field, not a consent purpose. Tag Assistant and the browser dev tools are in full agreement. That completes the walkthrough. We've seen how FitConsent configures consent mode v2 in the dashboard, how the embed script sets defaults and fires updates, and how all 4 signals are validated in both dev tools and Google Tag Assistant. FitConsent supports Direct Embed, Google Tag Manager, WordPress, and Shopify, with consistent consent mode behavior across all integration methods.